Dear student, today I am talking about image segmentations. So what do you mean by image segmentations? So image segmentation involves dividing an image into the meaningful stretches. These stretches defect the object that constitute an image. Segmentation is the first step in image analysis and recognitions. The different features in image are identified and extracted by the segmentation algorithms. Accuracy of the extracted features decided the accuracy of automatic recognitions, and so very carefully you have to be segmented some of the objects. By selecting the or selection of suitable algorithms is highly applicable dependent. Image segmentation is one of the most difficult tasks in an image processing. Usually in many general applications, many image processing tasks has to be aimed to finding a group of pixels in an image that are similar or connected to each others in some way. The image analysis, image representation or object representation, visualization, understanding, and some of the classifications to be done. So usually we are going to use many applications in image segmentations. So now I'll come to this slide. Image segmentation divides an image into the regions. We can split into that regions that are connected and have some similarity within the regions and some difference between adjacent regions. The goal of these image segmentations is usually find individual object in an image. For the most part, there are fundamentally two kinds of approaches to segment: discontinuity and similarity approaches. Similarity, it may be due to pixel intensity, color, or textures. The differences are sudden changes in any of these, but especially sudden changes in the intensity along a boundary lines, which is called the edge. So here in the detection or discontinuous, you look into that, some kind of diagram only. What do you mean by detection of discontinuity? There are three kinds of discontinuities of intensity. Usually in image processing, we considered points, lines, and edges. The most common way to look for discontinuities is to scan a small mask over the image. The mask determines which kind of discontinuities. By using that mask equations, you look into that equations. And we can consider with an image, please look into that image for detection of discontinuities point detections. Detection and discontinuities line detections by using only slight more common than point detection is to find a 1 pixel wide line in an image. For digital images, the only 3 points straight lines are used One is horizontal, vertical, and diagonal. So horizontal, these are the horizontal image. Then plus 45 degree, and then vertical, and then minus 45 degrees. Usually, the image segmentation is the fundamental steps in an image analysis, understanding, interpretations, and recognition task. In the process of decomposing a scene is nothing but an image into a different component. Segmentation portions an image into a multiple homogeneous regions with respect to some characteristics. In practice, it groups the pixels having similar attributes into the one group. As a result of image segmentation is a set of regions that collectively covers the entire image or a set of counter extracted from the image. In that part, each pixel in a particular region is similar to the other pixels with respect to some characteristics such as colors, maybe edge, texture, disparity, motion, etc. This segmentation is an intermediate stage between the low level and high level image processing task. Low level task manipulates pixel values for irregularity corrections or for example image enhancement. Whereas in case of high level task manipulate and analysis a group of pixels that convey some informations. Usually the image segmentation preferably we are doing with pre-processing techniques, image pre-processing techniques. So what do you mean by pre-processing? In many cases, image can be pre-processed in the different ways. Resizing. Enhancement also, some applications we are going to consider as a pre-processing. And now we'll come to some of the applications. I think look into the slide. How the image, original image, components of the gradient in the x directions in the B, C components in the y directions, D gradient images. And many cases, now mainly we look into that applications of image segmentations. Medical imaging, the segmentation is used to locate tumors, measure tissues, computer-aided surgery, diagnosis, treatment planning, study of anatomical structures. These are all belongs to the medical images. Second one, it is called as satellite images. In case of satellite images, segmentation is used to locate object like a roads, forest, etc. In the satellite images, for monitoring of ecological resource like regional dynamics of the vegetarians, deformations, mapping of underground minerals, etc. And then third application example, movement detections. Monitoring the crowded urban environment is a goal of modern vision systems. Knowledge of the size of the crowd and tracking of the motion can be used to monitor traffic intersections, intelligent walk signal systems, can be designed based on the number of people waiting to cross the road. Crowd control and planning urban environment. Security and surveillance. In many cases, security of national assets such as bridge, dams, tunnels, etc. is a critical in today's world. Automated smart system to detect suspicious movements, activities during the period of night. Left baggage vehicle is crucial for safety. Automated face detection systems try to match the criminals' faces in the crowded places. And then license plate recognitions, I think is very familiar applications, how to detect the license plate. This segmentation technique is very essential by using this. And industrial inspections and automations. Here the objective is to find missing components, integrated crucials in the printed circuit board PCB. For example, in the electronics, the PCB board is very important. And the last main applications, what we look into that robot navigations. So here, the robots are used in a variety of industrial, medical, and research applications. It helps to that navigate it. So many segmentation techniques, discontinuity, similarity, edge-based segmentations, threshold-based segmentation, region-based segmentation, cluster techniques, matchings, etc. So now we look into that vehicle, some edges. This example I'll show you some of the examples. See here, boundaries of that threshold. We can fix the threshold. Based on the threshold, we are going to detect it. Yeah. Threshold with basic global thresholding. Thresholding, basic global thresholding fingerprint. This is what we are all biometric techniques. Adaptive thresholding, we can adjust. Basic adaptive thresholding. So these are all things to be used in the optimal global and adaptive thresholdings. Okay, I hope that some, as per the examination point of view, what you mean by segmentation, what are the different segmentation techniques are available, and how we are going to use all these things, it will be mentioned in the slide and my explanations. Thank you. I will continue in the next concept. Okay, now we'll look into the next concept in the next class. Thank you very much. Thank you, one and all.